Hello viewers, in today's class we are going to solve some initial value problems, right? So here we are given a differential equation, and along with the equation we have a condition to determine the constant of integration, right? So such problems are known as initial value problems, right? So let us first take this problem. So here we have to solve the initial value problem. Dy is equal to e raised to 2x plus y dx, and y of 0 is equal to 0. So this is the condition which is given here, right? So let us start. So here this equation can be uh, rewritten as dy is equal to e raised to 2x times e raised to y dx, right? So here we have used the property that e raised to a plus b is equal to e raised to a times e raised to b, right? Okay, now we see that this differential equation takes the variable separable form. So let us separate the variables, and the variables are x and y. So we take e raised to y to the left hand side, and we keep the x variables in the right hand side. Clear? Okay, now this can also be written as e raised to minus y dy. Here we have e raised to 2x dx. Now we can integrate both sides. So integrating both sides, we have this expression, and here we have the constant of integration as c, right? Now the integral of e raised to minus y is minus e raised to y, and the integral of e raised to 2x is e raised to 2x divided by 2 and plus c, right? So here we have used the result that e raised to mx dx, where m is some number, so this is 1 over m e raised to mx, right? Okay, now here our aim is to find out the value of this constant by making use of this condition, right? So here we are given at x equal to 0 the value of y is equal to 0. So let us substitute these values in equation number 1 to get the value of c, right? So we have minus e raised to minus 0, and here we have e raised to 2 times 0 divided by 2 plus c, and e raised to 0 is 1, and here we have minus 1, and here we have e raised to 0, and e raised to 0 is 1. So here we have 1 over 2 plus c, and c is minus 1 minus half, that is minus 3 by 2, right? So this is the value of c. Now substituting this value of c in equation number 1, we can write this equation as minus e raised to minus y, and here we have e raised to 2x divided by 2, and for c we have minus 3 over 2, right? Okay, so now we'll simplify this expression, and we can multiply throughout by the negative sign. So we can write e raised to minus y, this becomes positive, and these two terms get reversed. So we have 3 by 2 minus e raised to 2x over 2, and this can also be written as e raised to minus y is equal to 3 minus e raised to 2x over 2, right? Now we can take the natural log of both sides, so we can write log e raised to minus y is equal to log of 3 minus e raised to 2x over 2, right? And by applying the property of log, we can write it as minus y, because log of e raised to minus y is minus y log e, and the value of log e to the base e is 1. So this is 1, and we have minus y times 1 is equal to minus y. So here we have minus y, and here we can write log of 3 minus e raised to 2x over 2, right? Now taking this negative sign to this side, we can write y is equal to minus log 3 minus e raised to 2x over 2, right? Now again, applying the property of log here, this expression can also be written as y is equal to log of 2 divided by 3 minus e raised to 2x, right? So here we have applied the property of log as minus of log a is equal to log of 1 over a, right? So this is the required solution of this initial value problem given this condition. Now let us take this problem. So here we have to solve this differential equation given the condition y of 0 is equal to 1. So let us start. So here this equation can also be written as dy over dx is equal to, taking this sign to this side, we can write it as sine inverse of k, right? Here k is some constant, and this differential equation now takes this form, right? Now here we see that when k is constant, then sine inverse of k is also a constant, right? And again, separating the variables, we can write dy is equal to sine inverse k dx, right? Now integrating both sides, we have this expression with c as the constant of integration, right? Now the integral of dy is y, and here this is a constant, so we can write it as sine inverse of k. Taking outside the integral sign, here we have integral of dx plus c. So now the integral of dx is x, so taking this x to this side, so we can write x in front of sine inverse of k. So we have y is equal to x sine inverse k plus c, right? So let us call this as equation number 1, right? So this is the general solution of this problem, and now let us utilize this condition to obtain the value of c, right? So we are given y of 0 is equal to 1. It means when x is 0, then y is 1. So let us substitute these values here. So we have 1, here we have 0 times sine inverse of k plus c, right? So we have 1, this term gets 0, so this is 0 plus c, so the value of c is 1, right? Now substituting this value of c here, we can write y is equal to x sine inverse k plus 1, right? So this is the required solution of this problem, right? Now let us take one more problem. So here we are given this differential equation dy over dx plus 2y square equal to 0, and the condition is y of 1 is equal to 1, right? So let us solve this problem. Now this differential equation can be written as dy over dx equal to minus 2y square, taking this 2y square to the right hand side. And now we see that this differential equation assumes the form of the variable separable form, right? So we can separate the variables, so we can write dy over y square, and retaining this minus 2 in the right hand side, we can write it as minus 2 dx, right? So we have separated the variables, and now integrating both sides, we have this expression, and c is the constant of integration, right? So the integral of 1 over y square is the negative of 1 over y. By making use of this rule, that is integral of x raised to n is x raised to n plus 1 over n plus 1, where n is not equal to minus 1, right? Okay, so we have here minus 1 over y, here we have minus 2x plus c, right? Now we have to find the value of this c, the constant of integration, by making use of this condition. So we are given y of 1 is 1. It means when x is 1, y is 1, right? So let us substitute these values over here. So here we have minus 1 over 1, and here we have minus 2 times 1 and plus c, and this is minus 1 minus 2 plus c, and c is minus 1 plus 2, that is 1. So the value of the constant of integration is 1, and let us substitute this value here. So we get minus 1 over y is equal to minus 2x plus 1, and multiplying throughout by a negative sign, we can rewrite this expression as 1 over y. Here it becomes plus. Here also we have the positive sign, and then we have the negative sign. So now this can also be written as y is equal to 1 over 2x minus 1. So this is the required solution of this differential equation when this condition is given. Now viewers, let us take one more important problem. So here we are given the differential equation dy over dx is equal to 2 times e raised to x y cube, and the condition is y of 0 is equal to half, right? So let us solve this problem, and again here we see that we can separate the variables. So separating the variables, we can rewrite this differential equation as dy over y cube, and here we'll have 2 times e raised to x dx, right? So we have separated the variables, right? Okay, now integrating both sides, we have the integral of 1 over y cube, and here we have the integral of 2 times e raised to x dx, and c is the constant of integration, right? Now the integral of 1 over y cube is minus half y square, right? So here also we can make use of the result, that is x raised to n dx is equal to x raised to n plus 1 over n plus 1, where n is not equal to minus 1, right? So the integral of 1 over y cube dy can be written as y raised to minus 3 dy. Then we applying this rule, so we have minus 3 plus 1, then minus 3 plus 1, here we have minus 2, here we have minus 2, and this is minus 1 over 2 y square, right? Okay, and here we have 2 times e raised to x plus c. The integral of e raised to x dx is the function itself. So we have this equation, right? Okay, so now our aim is to find out the value of this constant of integration by using this condition. So we are given y of 0 is equal to half, and it means at x equal to 0 we have the value of y as half, right? So substituting this value, these two values over here in equation number 1, we have minus half here, then y square is half square, so we have 1 over 4 here, then we have 2 times e raised to 0 plus c, right? So here we have 2 to the 4, and this taking this 2 to the numerator, we can write minus 2, and here we have 2 times 1 plus c, because e raised to 0 is 1, and we have minus 2 is equal to 2 plus c, and c is minus 2, that is minus 4. So the value of c is minus 4, right? Now let us substitute this value over here. So now we'll get the expression minus 1 over 2 y square is equal to 2 times e raised to x, and for c we can write minus 4. Clear? Now multiplying 2y square and this term, we can rewrite this expression as minus 1 is equal to 2y square times 2 e raised to x minus 4, and now multiplying throughout by minus 1, so this becomes positive 1, and here we have 2y square, and these two terms gets reversed, so we have 4 minus 2 e raised to x. So we have multiplied this equation by minus 1, right? So now we can write this expression as 2 4s are 8, so we have 1 is equal to 8y square minus 4, 2 2s are 4, and here we have y square e raised to x, or this can be written as y square times 8 minus, here we can write 8 minus 4 times e raised to x, right? So this is the required solution of this differential equation when this condition is given.